Good day, guys. Welcome to another video session of PLC simulator program. Today we will be talking about something about the business proposals, and I will show you one ladder logic and graphics program made for a boiler sequence control. So before we do that, uh, if you see, my all four videos are shown here. PLC for the training. It consists from basic to advanced. So this will be my fifth video, which will be uh, talking about some business and also one complicated logic controller for steam boiler, which has been made. So these are the four links URL. You can watch my video serially so that you will understand. Start from 1, 2, 3, 4, and you will then come to know more about programming and graphics. Okay, this is the thing. And another thing, here we have this one more thing is about business information is, as I have already shown in my other videos, you will get, you purchase the software, you get the programs and graphic software. Another one is a copyright protection with soft training manuals, speed training, and after sales. So these are my contact details, which you can contact me anytime. Okay, now apart from that, I also provide a physical PLC which you can use it in the industry. It is based like this is the one. This is the IO card. Uh, this is the IO card, 32 input, 32 output, and this is the controller card. So this is the motherboard, and this is the controller board, and also this is the IO cards details. In fact, this is the PLC input card. This is the 8 input, and this is the configuration of that. So this is the printed circuit board. Then we have PLC output. Okay, and again it's a 8 output card. So I also provide this service if anybody is interested, and he can use it physically, input from the field and output to the field. So all this also will be provided by me. These are all hardware, so you can make a physical PLC. It depends on your what is your input and output. So also I provide relay interpose, but these are some relay interpose bases depending on your what kind of output devices you are using and their current rating. The relay configuration will be decided. So okay, now we will start with the one boiler control. So let me just open this and so that we can talk about it more in detail. So I can start this program. This is second. Okay. File open. Okay, it says the furnace logic. Okay. This is a logic page. As you can see, it's a very complicated logic here, using timers, using set block, reset blocks. Okay, and okay, now we open the graphics page. Now fault finding on this program card will be difficult. So I will show you an example how it becomes easier when you see the graphics page for fault finding. So we'll run the graphics page. Okay guys, now basically what you see here is a graphics page, and okay, now this is a fuel tank diesel. This is our boiler chamber. this diesel will be provided, and there is a blower. This is coupled with the diesel, and this igniter here, and this is overhead tank, and overhead tank, the level will keep on feeding water the to the boiler. So here what we need to know here is basically the control narrative says there are some permissives. So there are 5 permissives. It could be anything, level low or level normal, water level normal. Okay, all breakers are in position. This you decide depending on what are the permissive required for the boiler to run. Okay, I've just written it as okay and not okay. So basically what we now we run this program now. Okay, and minimize it here, and now as you see, input 0, input 1, input 2, input 3, input 4, 5 are the permissives. Okay, now the start command is number 10, this 10, reset input 31, and since this is a simulation, so when the ignition comes on, so we energize this to tell the boiler that the flame is on. Okay, now the narrative says when you start, the blower will purge, feed pump will start, and a purge will start. It will purge the furnace. After purge is over, ignition will start, and we'll see here 2 conditions, 3 conditions rather. First we start and we don't generate the flame. What happens? Then we start again, and any one of the inputs we can, okay, say make it off. So let's start now. We will now run this also. You see now here. So here, okay, input 1 okay, input 2 okay, input 3 okay, input 4 okay, input 5 okay. Now all the permissives are there, and as I told you, 31 is my reset. So I press 31. Now permissive is okay. Now I can start the boiler. I give a start command which is input 10. Okay, I start the command. As you see, purge on comes online, purge timer starts. This is the timer for the purge. After that, ignition is on, ignition timer is on here. So okay, now after ignition is over, you have an alarm. Why you have an alarm? Because the flame detection was not detected. Okay, so you have a flame out. Okay, now we reset again. Okay, reset again and again give start. Now what we will do, we will, after the ignition time is, between the ignition time, we give the flame detection as detected. Okay, now let's start. Pulse is on. You see blower is on, feed pump is on, permit is okay. After that you have, then ignition is on, timer is on. Now I will give this flame. Now you see, now the boiler is running and you have flame detection. So in the graphics it's very easy to tell you what has gone wrong. So now assuming now the boiler is running, everything is healthy, so we lose one of the inputs. So the moment one of the input is lost, okay, you see here blower is off, flame is off. Okay, now since we are on manual mode, we have to remove this flame detection. In real process, the flame will already be off because the detector will see that. Now since it is in simulation mode, we remove this signal, and what now we come to the graphics page and see input 1 is not okay. Okay, rectify the fault, make it normal, and then you can restart the boiler. Okay, start command given. Oh, we have not given reset here, so we have to give reset. Once the reset is given, you can use start command. Pulse on is there. Okay, ignition on has come and the flame has come. Okay, so this is the way logic can be made depending on a narrative available, and you see how big this logic is. Okay, it has gone up to 30 columns here, 30, no, row number 30. So this is how big the program is. So guys, this is the way you can make graphics and a PLC, and do the simulation, check the software, and do all the fault findings, and then implement the logic in your system. That's it, guys. So if you are interested, please uh, go through my documents, and I will provide you any support if you purchase the logic from me. Okay, see you guys now in my another video.